So here is question number 46, everyone. Assertion: a pair of coils can have self-inductance without having mutual inductance. Alright. We know very well, for the coefficient of coupling, K will be given as M upon under root L1 L2, where L1 is self-inductance of coil 1, L2 self-inductance of coil 2, and M is the mutual inductance, where K is coefficient of coupling. Now, when plane of two concentric loops are perpendicular to each other, then mutual inductance will be 0. Okay. Now, if two coils are oriented at 90 degree to each other, so no flux of one coil is linked with other. If coils are perpendicular, so what will happen? K will be 0 and therefore mutual inductance will be 0. So reason is also true, assertion is also true, and explanation is also true. So we will go with option number 1 only. Move on to the next, that is 47 number. Question number 47, everyone. The average value of AC in practice is calculated for positive or negative half cycle. Definitely it is true, it is completely true. I average we have written as 0 to T by 2 I dt upon 0 to T by 2 dt. So this is the expression for average value, and therefore assertion A is correct. Now let us talk about the reason. The average value of AC during half cycle can be positive, negative or 0. Okay, this can be proved or shown using the curve. Suppose we have a sinusoidal curve. Now this is quarter cycle, or if we are taking for this half cycle, upper average value goes positive. If we are calculating this for negative half cycle, average value will be negative. So it can be positive, it can be negative. But if we are calculating the average value for half cycle from this to this, so that can be 0 as well. And hence we can say that reason is also true, but there is no interlinking between them, no relation. Option number 2. Move on to the next, that is 48 number. So here is question number 48, everyone. The mirror formula 1 by V plus 1 by U equals 1 by F is for spherical mirror is valid only for mirrors whose size are very, very small compared to their radii of curvature. Okay. The assertion is completely true. Why? Because during the derivation we take only the paraxial rays and aperture small. So that's why assertion is true. Now let's talk about reason. The law of reflection are strictly valid for plane surfaces but not for irregular. Wrong, because law of reflection will be valid for any kind of surface, whether it is regular or irregular. So now therefore we can say that option number 3 is correct. Assertion true, reason false. Option number 3. Move on to the next, that is 49 number. So here we are having question number 49, everyone. A simple pendulum swings back and forth in circular arc. The acceleration of bob at extreme positions is 0. Okay, let's see. In the motion of pendulum, we know that acceleration is given by minus omega square into x. At extreme position, x is maximum, acceleration would be the maximum. It is not 0, so assertion goes false. Now let's talk about the reason. The magnitude of tangential acceleration at mean position is maximum. Now we know very well at mean position x equal to 0. At mean position x equal to 0, therefore acceleration would be the 0. It means assertion is false, reason is false. So therefore we can say that option number 4 is absolutely correct. We can go with fourth option. Move on to the next, that is 50 number. Here is question number 50, everyone. Assertion: a particle always moves in the direction of net force acting on the particle. This may be true, this may not also be true, because if you think about circular motion, particle moves tangentially, means particle always moves perpendicular to centripetal force. So this is not always happens. This may happen or this may not be happen, but assertion says always. That's why A is what? Wrong. Let's talk about the reason as well. Acceleration always increase the velocity. No, it is not possible. Acceleration may decrease the velocity as well. If it is retardation, then it will decrease the velocity. So reason also goes wrong. Therefore, A false, R false, option number 4 we can go with. Now move on to the next, that is 51 number.